Yeah, thanks for coming back again. If you're a subscriber of this channel, and if you're new here, take to click on the subscribe button and also on the notification bell. That will let you know when we drop a new video. So we want to look at the question here. The question is all about a shape called ellipse and a circle inscribed in it. So if you're familiar with ellipse, you should know some properties about it. So we are going to explore this question and how to solve it. So let's start by analyzing it. We have the ellipse. This is a diagram here, as you can see at the beginning of the video. So you have a circle inscribed in it such that the circle touches the origin, that's the center of the axis of the ellipse. Now, maybe before we continue, we should just define what an ellipse is. You know, when you say a circle is formed when a body moves such that it is at a fixed distance from a point. Take for instance, if you are to move such a way that you are always 2 meters away from a tree, so which means you cannot go beyond 2 meters away from that tree, so the tree will be in the center, you will continue moving around the tree, so then the part you will create, which we call locus, is a circle. Now we have ellipse. Ellipse is another shape. So I know majority of you will say oval. No, this is not oval. Oval is a solid shape of ellipse. Just like sphere is a solid shape from, if I draw this now, this is a sphere, and this sphere is made up of circles. So this is ellipse. Oval is made up of ellipse. Are you getting it now? So that is it. Oval is a solid shape, meanwhile ellipse is the plane shape. So now, if you are to define a circle now, you say circle is the locus of a point equidistant from a fixed point. Just like I said, when you are moving 2 meters away from a tree, so you form the circular path. Now, ellipse is the locus of a point moving in a plane, when they say plane, the Cartesian plane, such that its sum of its distance from 2 fixed points is constant. Anyway, to this question, we don't need much stories. If you want to understand ellipse and how to derive the equation, that means you have to watch this video to the end. We explore that at the end of the video, but let's explore this question first. So now, looking at this now, if you have this circle inscribed in the ellipse such that it makes a point, it touches the ellipse at this point labeled P, and the radius of that circle makes an angle theta in this manner, and this radius also extends to the point of contact of the circle with the vertical axis. Now this point is always called A, while this is called B. Good. The general equation of ellipse shows that you should give P a position on the Cartesian plane. So the position of P corresponds to a particular value on X, so let's put that X, then correspond to a particular value on Y, so let's call that Y. So this position is prerequisite to what we want to solve. Now, what is the relationship between the circle and the ellipse? You might be thinking, yes, there is a geometrical relationship. Yes, it is. There is. If you look at it very well, they touch each other, that's one. Then the radius of the circle make an angle this. So let's explore it more. This P is not just XY. We need to explore the position. So how do we go about that? So if you look at this theta here, plus the angle between the two radius, okay, permit me to draw the diagram again, or if you can see it very well. So this is it here again. So we can have a bigger look of what I'm saying. So now, this is the radius, and this is the radius as well, then this is angle theta. Now, this theta here, plus whatever angle this place might be, would be 180 degrees because they are angle on the straight line, so which means this particular place, let's label that angle alpha. So angle alpha plus theta should be 180 degrees, so that means alpha is 180 minus theta. So the value of the angle here is 180 minus theta. Now, this is P. let us connect this point here down to point P. We form a triangle. So, which means connecting this point down here, we form a triangle. And definitely, the triangle is going to be isosceles. Why? Because as we form a triangle, we discover that the angle here is 180 minus theta, and the length of the two sides of the triangle are equal. So let's sketch out the triangle here. So the triangle is this, where here is R, anyway, not 90 degree. So let's manage that. So here is R, here is R. Don't forget, we have angle theta here, according to what is here. Then this place is going to be 180 minus theta. So for this side to be R and R, that signifies the triangle is isosceles. So, and for isosceles triangle, the base angles are always the same values. So which means the angle here plus the angle here are the same value. So if I pull them to be beta, beta, that's a symbol. So which means this beta and beta is the same value, okay? So now the sum of these three angles is 180 degree, because they're sum of angle in a triangle. So which means 2 beta plus 180 minus theta equals 180 degree. So that is the implication of that. So now what are we going to do next? 2 beta plus 180 minus theta equals 180. So if I bring my 180, I'm going to be having 2 beta whole equals, 2 beta minus theta equals 180 minus 180 would be 0. So bring my theta here, I'll be having 2 beta equals theta. So beta is going to be what? Theta over 2. So which means the angle here is theta over 2. Agreed. Oh, that's great. So now the next thing is to explore. We are trying to use these angles to get the position of P, the value of the position. So now this is the general equation of ellipse: x squared over x squared plus y squared over b squared all equals 1. So if you want to know how to derive this equation, you have to watch this video to the end. After we solve this question, we explore why the equation of the ellipse is this. So now the next is, when you have this straightforward, all you need to do is, let us try to test the position of P. So now I will say here now, this is point P, and then if I would look at it on this axis, the line, the dotted line here that goes to P, this is A. We can say we can resolve it into 2 dimensions. That is A cos, the value here, A cos beta, and we have B cos beta. So that will be the position of P. And what I'm saying in essence is that, so this is it. Don't forget there is a vertical axis here. That's Y. So you have the point B there, which is at this particular point. Don't mind my drawing anyway. So now this point B, this point B, I can write it as B sine theta corresponding to the value of P. Then I can have A cos theta. So this A cos theta is for the horizontal, cos beta, cos beta. Don't forget, beta is theta over 2. So agreed. We might not even, we just have to show you this. So now the coordinate of P, which is P x y, will be the same as A cos beta and B cos, A cos beta and B sine beta. So this is the position of P. So we have found the position of P. So finding the position of P, we can actually prove it, that is the position of P. So how do we prove that that is the position of P? we can substitute this value into the if x is this and y is this, let's substitute into what we have here and see if the answer gives us 1. So here we have x squared over a squared plus y squared over b squared equals 1. So now x is going to be a cos beta. So are we having a cos beta squared over a squared plus y sine beta squared over b squared. So let's see if this expression gives us 1. So this gives us a squared cos squared beta over a squared plus y squared, sorry, this should be b, so plus b squared sine squared beta over b squared. So this cancel this cancel this. Now whenever you have cos squared beta plus sine squared beta from trig identity, oh sorry, you can see that. So let me just continue here. So from this point here, why this cancel this and this cancel this? Whenever you have cos squared beta plus sine squared beta from trig identity, this must give you 1. So we have proved that this is the position of P. So having proven that that is the position of P, then we can proceed to find the radius of the circle. And we have to redraw the triangle again. So if I want to draw the triangle, I'll draw it like this. So this is r. So 180 minus theta, don't forget. So we only find beta because we wanted to prove the position of P. So after that, don't forget theta is actually here, theta. So this is point P. Using cosine rule, if I want to find from length O, don't forget the origin is OO. From here, this is the origin, so it's OO. Now, to P, that is distance, OP, how do we find it? So we can say the origin, OP squared, as the length from here to here, OP squared, all equals to, you now have the angle that opposites this is 180 minus theta, then you have r squared plus r squared minus 2r dot r cos 180 minus theta. So that's cos the value here. So now what is OP squared? So how do we find the value of OP squared? So we know the coordinate here is a cos beta, so which we can turn to theta over 2, and we know the coordinate here is b sine theta over 2 as well. So how do we find the distance from here to here, which is OP? So the distance is actually when you use the distance formula. So the distance formula is you have OP equals x2 minus x1, that is a cos theta over 2. You are going to square that, squared, plus, then you have b sine theta over 2, then you square that as well. So which means this minus this, you square that, this minus this, you square that, so you find the square root of everything. So I think OP is this, but you can take the square root of both sides because we need OP squared. So OP squared will be a cos theta over 2 squared plus b sine theta over 2 squared, which you could write as a squared cos squared theta over 2 plus b squared sine squared theta over 2. So we place it there. So placing this here, everything here becomes a squared cos squared theta over 2 plus b squared sine squared theta over 2. Then r squared plus r squared gives us 2r squared minus, this is also 2r squared. Now whenever you have 180 minus theta is the same thing as minus cos theta. You get that? So which means we are going to have a squared cos squared theta over 2. Are we following? Plus b squared sine squared theta over 2 all equals this times this will be positive, so definitely we're going to have 4r squared minus 4r squared. By the time you multiply this and this you get positive. You can add that straight away, so 2r squared, then plus you're going to be having 2r squared cos theta. Okay, this is where we are. Let's move on again. What next is we have to factorize here and simplify everything together. So to do that, we have a squared cos squared theta over 2 plus b squared sine squared theta over 2 all equals, if you factorize here, 2r squared is common, then you'll be left with 1 plus cos theta. Okay, good. So then we can divide both sides by 1 plus cos theta, and this is all over 1 plus cos theta. So 2r squared equals a squared cos squared theta over 2 plus b squared sine squared theta over 2 all over 1 plus cos theta. So then what next? You have to divide both sides by 2 and then find the square root of both sides. So if I divide both sides by 2, so which means I'll be having r squared equals a squared cos squared. Then we can change these to beta, take note, plus b squared sine squared beta all over 2 into 1 plus cos theta. So take the square root of both sides. If you take the square root of both sides, r is gonna be square root of a squared cos squared beta plus b squared sine squared beta all over 2 into 1 plus cos theta. So whatever the value of theta would be in numerical form, you can plug that here, and you know this beta is theta over 2, so whatever the value is, you could find the radius of the circle in that ellipse. So you may be thinking, how do we simplify this further? You can actually simplify further if you want to do that. So you have to do some manipulations if you want to simplify your answer to be smaller than this. So the radius of the circle is just this. Yeah. So we move to what ellipse is. Yeah, so we continue with what an ellipse is. As I've said earlier, ellipse is the locus of a point moving in a plane such a way that the sum of its distance from two fixed points is constant. So what are the two fixed points and what are the parts of the ellipse you must know? So we have these to be the center of the ellipse. Now these points are called the vertices. Vertices of the ellipse. So this one will be vertex 1, and this is 2, this is 3, and this is 4. Now, there is a distance along the horizontal positive axis x, and this is horizontal negative axis. So vertical negative and vertical positive. Are we noting that? So this point here is called the focus. So I call that focus 1. Then you have two foci, so this is the second one here. Now, when a body is moving to form an ellipse, the sum of the distance of that body from these two fixed points is constant. So take a look at point P, look at this line from the first foci and this line from the second foci. So if you add the distance, let's say P, if you add the distance from P to first foci with the distance from P to the second foci, that means I'm talking about P to F1 plus P to F2 is a constant value. That means for every position around this ellipse, the sum of the distance, okay, if the position is here, the sum of the distance of year to year will still be the same as when it is here. Let's use that words. So now, if P is here, don't forget that the distance will be something like this and like this. If you add this with this again, it will give you the same value as adding this to this. That is why they said ellipse is the locus of a point moving in a plane such that for every part of the ellipse, the sum of the distance of that part from the two fixed points, when you add it, is going to be the same value. So then what is the value of this constant? So we need to analyze the value of this constant before we begin to move on. So there are other things before we analyze the value of the constant. So you know that the sum of the distance of any part on the ellipse to these two fixed points is always constant. So now, this position is called A, while this one is B. A is always greater than B. Why? Because if you look at it, it's wider and this one is a little bit smaller. So this is negative A, this is positive A, this is positive B and negative B. So each positions have their coordinates. Just like A now, A we have a coordinate A and 0 because no value on Y but A on X. So this would be negative A and 0. So this will be 0 with B, while this one will be 0 with minus B. What about the foci? The foci, we have their own coordinates too. So F2 is going to be less negative C with O, and this will be C with O. So let's put it that way. So the position here along x-axis is C, but on y-axis is 0, then negative C and 0. So now, if you have the first vertex to the second vertex, if you look at it, so from here to here is A. From this 0.0 to A has a length A. Then from here to here also have a length A. So which means from this V1 to V2, V1, V2 is more or less like A plus A. Don't mind the negative, so we are going to call that 2A. So from here to here is 2A. This is half, this is half. Now we are trying to get the value of the constant. Good. Suppose the ellipse, the point we are talking about on the ellipse is not this. We want to talk about when the body is around here or around here. But let's pick this point first. If the body is here and not here, the sum of the distance from two fixed points will still be the same. So which means we have, let me draw a diagram again so we can get the explanations. So now, look at it here. I don't have to put those labels since you understand them. So now, if point P is here, point P has a coordinate x, y. Do we know that? So which means at V1, the coordinate is still x, y because that's the position where we are working with. Then we have the foci here, F1, and the foci here, F2. So the foci has negative C with 0 and positive C with. So now what next? The distance from here to here is also the same as from here to here. So let's label it V2, V1. So we are saying V to F2, that's from V2 to F2, is the same value as V1 to F1. So this to this must be equal to this to this, and from here to the center must also be equal to this. This diagram is not drawn to scale. So now what next? We need to analyze certain things. So now the coordinate of this is xy. The sum of the distance of this from two fixed points. Now the point is here. Don't forget when it is here, we are to add the distance from the first foci plus the second foci to give us that constant. So now it is here. So the distance from the first foci will be this. And from the second foci, we are going to have this with this with this. Okay? So which means we are going to sum F2 V1 plus what's it called? F1 V1. So this is the sum of the distance from the first foci to this point plus this second foci to this one. So the sum of these two distance, this plus from here to here. So if you analyze it very well, let's analyze it very, very well. Let's look at it vividly. When you add the distance of here to here plus here to here plus here to here, it must give you 2a. So which means from here, don't forget this statement, v1, v2 is 2a. So from here to here is 2a. Now, you are adding the distance, this plus from here to here. It's more or less like you are adding times 2 of this with from here to here. Let's just put it that way. Let's understand it in such a manner. When you are adding the two distance to get the constant, from this fixed point, the distance from here to here is the distance of the point from the first foci. Now, the second foci distance from this point is from here to here. You do not call it here to here. It has to be from second foci to the point P. So we have to use this to analyze so that we can get the value of this constant. So now, from here to here is the first distance from the first foci. Then from here to here is another distance. So if you look at it, this is first distance. So let's call that A over 2. Plus, now you are adding from here to here. That's from here to here is A over 2. Then you are adding the whole length from here down to here again. So which means another A over 2 is here. A over 2. Then what about the distance from here to here? 1, 2. So that's another A over 2. Plus from here to here is another A over 2. So this is 1, 2, 3, 4. Adding it together, you'll be having 4a over 2. So having 4a over 2, if you break it down, you're going to be having 2a. So which means that the sum of the distance of any point on the ellipse from the two fixed points is always 2a, is always constant, which is the constant is 2a. That is the meaning of the statement. So the constant is 2a. So if the constant is 2a, what are we going to do? I said from here to here is a over 2. That's the distance of point P to this point, which is the first one, similar to this. Don't forget, the basic of understanding this is that the sum of the distance of any part on this ellipse from two fixed points, which is these two foci, must be constant. So if the point is here, from the first foci you have this distance, from the second foci you have this distance, the sum of those two distances must be constant. So what is the value of the constant? So we now try to bring the point back to V1 and analyze so we can get the value of the constant. So the first distance from F1 is this, so that was A over 2. Then the second distance is from here to here, which is like 3 times the distance of this place. So when we added it, it gave us 4 times that distance, so which eventually becomes 2a. So since we have 2a as the constant, then we can proceed to find the equation of the ellipse. So now, let's move on. Good. So in order to move on, we know that the constant is 2a, so the sum of this distance from here to here, now the coordinate of this is xy because that is where P is. So how do we find the distance from here to here? So the distance F1 to V1 or F1 to P, F1 to P is square root of, now don't forget, x minus c all squared plus y minus 0 So that's y minus 0 all squared, so which is still y squared. Now, what about the distance from here to here? So, and that would be f to p, and that would be square root of, you're going to have x minus c, so that will automatically give us x plus c squared plus, then you now have y minus 0, which is still y squared. Y squared. Now, we said this is the distance from here to here, and this is the distance from here to here. The sum of this distance must be 2a, right? So, which means square root of x minus c all squared plus y squared plus square root of x plus c all squared plus y squared. Don't mind me for changing the y, must be 2a. So from this expression we can get our equation. We can easily get our equation. So how do we go about that? These to the other side. So I'll be having square root of x plus c all squared plus y squared equals 2a minus, then you have square root of x minus c all squared plus y squared. So squaring both sides, I'll be having this to be x plus c all squared plus y squared all equals, if you square this side, you're going to have 4, okay, square both sides, d squared. So you have to use this to multiply these 2 times. So you have 4a squared minus 4a root x minus c squared plus y squared. Then you now have plus the expression itself, that is x minus c all squared plus y squared. So from here we can simplify this side and expand these so we can get what we want. So here will be x squared plus 2cx plus c squared plus y squared equals 4a squared minus 4a root. You have x minus c all squared plus y squared plus this will give us x squared minus 2cx plus c squared plus y squared. So if you look at it, y squared is positive here and also positive here, so it means they will cancel out. Then 2cx is negative, positive here, negative here. That means if you take this here, it's going to become minus. Then this is positive and positive, so they would cancel out. Then also c squared is positive there and is also positive here. So having that, what will be left at this side is 2cx all equals to 4a squared minus 4a root x minus c all squared plus y squared. Then this would be minus 2cx. I have a root x minus c all squared plus y squared all equals a squared minus cx. So this is a squared, so let's divide both sides by a and a, so this goes. So then you have x minus c squared plus y squared equals a minus c over ax. Okay, good. So we can square both sides now. So we have x minus c squared plus y squared. After squaring both sides, then you have this minus c over ax all squared. Let us expand both sides. So this will give us x squared plus 2cx plus c squared. So minus 2cx, plus y squared. So then we expand this. We be having a into a minus c over ax, then minus c over ax into a minus c over ax. So x squared minus 2cx plus c squared plus y squared is equals to a squared minus, this we go with this, so you have cx, then this will also be minus cx, okay? Then here you'll be having positive c squared over a squared x. So having this, x squared minus 2cx plus c squared plus y squared equals a squared minus 2cx plus c over c squared is over a squared x. So this is positive here and this is negative here, so they cancel out. So you have x squared plus y squared plus c squared all equals, then you have a squared plus c squared over a squared x. There is a mistake earlier, so we just have to put this there. So and this is it. So this has gone with this, so you have this here. So we can actually bring this to the other side, x squared plus c squared over a squared x squared plus y squared, then plus c squared all equals, this would be a squared. So what next? If I factorize this, I'll be having x squared into c squared over a squared plus, c squared, that's 1 plus c squared over a squared. Yeah, because hex common, so bringing out the hex, this is what you have, plus y squared equals a squared minus c squared. So having this, we can actually add this to have x squared into LCM is a squared. So this over 1, so you have a squared. Then from there, I think bringing it here should be minus, so we are adjusting that to be minus. So we have minus c squared plus y squared equals a squared minus c squared. So now let's divide all through. If we multiply or divide all through by a squared minus c squared, so which means I will divide here by a squared minus c squared, a squared minus c squared, and this will be times 1 over a squared minus c squared. So this we go with this, and we have x squared over a squared. Then from there, this will be 1 plus y squared over a squared minus c squared equals 1. Then don't forget that, take notes from what we have here. A squared equals b squared plus c squared, so which means a squared minus c squared should be b squared. So we just have to change this here to b squared. So the equation of the ellipse we have been looking for is x squared over a squared plus y squared over b squared all equals 1. So that is the equation of the ellipse.